Hey everyone, and welcome back to the channel where we break down complex numerical methods in a simple and visual way. In today's video, we are diving into one of the most powerful and widely used root finding techniques in numerical analysis, that is the Newton-Raphson method. So, from lightning fast convergence to some serious limitations, we will cover both advantages and disadvantages that you need to know. So, let's get started. Firstly, we are going to discuss about the few main advantages of Newton-Raphson method. So the first advantage of a Newton-Raphson method is fast convergence. The Newton-Raphson method is known for its very fast convergence, especially when your initial guess is close to the actual root. It uses the slope, or we call it a derivative, of the function to quickly jump to the root, often within just a few iterations. Second advantage is quadratic convergence. The method has quadratic convergence, which means that the error decreases exponentially with each iteration. In simpler terms, once you are closer to the root, the number of correct digits nearly double with every step. The third most important advantage of Newton-Raphson method is they can handle complex roots. Unlike some methods, Newton-Raphson method can also find complex root of nonlinear equations, making it more versatile in engineering and scientific computations. The fourth most important advantage of Newton-Raphson method is that it requires only one initial guess. Requires only one initial guess. Unlike the dissection method, which needs two starting points, Newton-Raphson methods requires only one initial guess, making it more straightforward to begin with. Fifth most important advantage of NR method is efficient for well-behaved function. For functions that are smooth and have a well-defined derivative, this method works extremely efficiently, providing accurate result with minimal efforts. Next, we are going to discuss few disadvantages of a Newton's Raphson method, or simply we call it NR method. The first disadvantage of Newton-Raphson method is requires derivative evaluation. The biggest drawback of the Newton-Raphson method is that this method requires the derivative of the function, which isn't always easy to calculate. In some cases, the derivative may be complicated or even unavailable. Second disadvantage is may diverge if initial guess is poor. So, if your initial guess is far from the root, the method might diverge instead of converge. So, it can lead you further away from the solution or get stuck in an infinite loop. Third disadvantage is fails at inflection point, or we call it a zero derivatives. If the derivative at any step becomes zero, the method will break because division by zero isn't defined. This makes it unreliable near inflection points or flat regions of the curve. The fourth disadvantage is not suitable for discontinuous or non-differentiable functions. Not suitable for discontinuous or non-differentiable functions. So this method does not work well with functions that are discontinuous or non-differentiable since the tangent line approaches fails. The fifth disadvantage is sensitive to multiple roots. So in some cases where the function has multiple roots or repeated roots, the Newton-Raphson method can converge very slowly or may converge to a wrong root entirely. So to sum it up, the Newton-Raphson method is a powerful and fast technique for solving nonlinear equations, especially when you are dealing with well-behaved or smooth functions. But it comes with some risk like divergence, sensitivity to initial guesses, and dependency on the derivative. So use it wisely. So if you found this video helpful, make sure to like, comment, and subscribe to stay updated with more videos. So thank you so much for watching. Take care of yourselves.